Section 5.1, Rational Expressions and Functions, Multiplying, Dividing, and Simplifying. Rational expressions are fractional forms in which the numerator and denominator are polynomials. Let's recall the fundamental principle of fractions. For all polynomials p, q, and k, where q and k cannot be equal to 0, if you have a fraction of two polynomials, p over q, then you can multiply both the numerator and the denominator by k, the same polynomial. We know that with fractions. With numbers it's easy. So if you have 2/3, you can multiply numerator and denominator by the same number and you will get an equivalent fraction, 10/15. So you can multiply the numerator and denominator by the same number. You can multiply in rational expressions the numerator and denominator by the same polynomial. You can go backwards too. If you have 10/15 and you realize, hey, 10/15 is 2 times 5, 15 is 3 times 5. Once you factor both the numerator and denominator, you can cancel out any common factors and reduce the fraction to 2/3. So we're going to be doing the same thing with polynomials. Let's look at some more numbers first. We can multiply or divide both the numerator and denominator by the same non-zero expression. So we could multiply numerator and denominator just like we just did with 5 and get 40/50. We can also multiply numerator and denominator by something like x plus 1. Why not? There's a restriction here. What would cause a problem with this? X cannot be -1. So that would give us 3 times x plus 1, or 3x plus 3, over 7 times x plus 1. Recall that a fraction is in reduced or simplest form if the numerator and denominator have no common factor other than 1. So let's simplify some fractions using the same rules that we do with fractions involving numbers. We're looking for common factors in the numerator and denominator. There's different ways to do this. Let me show you kind of the long way, and then we'll look at the short way. So if you have 18, 18 is 2 times 9, and 9 is 3 times 3. Then you have x, and then you have y to the third. So that's y times y times y. I think you can see why we don't want to do it this way every time. 30 is 2 times 15, which is 3 times 5. Then you have x squared, which is x times x, and you have y. So we have a common factor of 2. 2 over 2 is 1, so there's no point in writing it. 3 over 3 is 1. There's no point in writing it because 1 times anything is just that thing. Notice that these x's, x in the numerator cancels with an x in the denominator, and a y in the numerator cancels with a y in the denominator. So that gives us as our answer 3, and we have y squared in the numerator. We have 5, and we have x in the denominator. But that was really quite painful to do. Let's see if there's some shorter way to do it. Let's write the problem down again. So we have 18 xy to the third over 30 x squared y. Now, 6 will divide evenly into 18. It will go 3 times. 6 will go into 30 5 times. You have x over x squared. One of those x's will cancel with one of those x's in the denominator. That leaves you an exponent of 1. Then you have y cubed over y. that y in the denominator will cancel with one of those y's in the numerator. So that leaves us with y squared. So that's 3y squared over 5 times x. And that should be to the first power. So we get the same answer whichever way we do it. It's a matter of how you want to think about it. Some of these other problems are a little different. Let's look at this one. So we want to cancel, but we cannot cancel until we factor. This time you actually have to factor. There's addition here. So in the numerator there are two terms. Never cancel terms. Only cancel factors that are separated from the rest of the problem through multiplication. So our common factor in the numerator is x to the smallest exponent present. When you factor that out, you are left with x plus 5. So now we have two factors in the numerator, and our denominator is 5x squared. We can cancel this factor of x squared with this factor of x squared in the denominator. That leaves us with x plus 5 over 5. Now somebody out there is saying, hey, let's cancel those 5's. No. This 5 in the numerator is a term. It is separated through addition from the x, and so you cannot cancel it. Let me show you why. Let me make up a problem over here that has nothing to do with this, really. If I have 2 plus 7 over 7. Now I know that this is 9/7. I know it is, because 2 plus 7 is 9 and it's 9/7. If you think you can cancel this, you would get 2. That's not right. You cannot cancel this. You're messing with the order of operations. You're doing the division before you do the addition. You can't do that. It's understood you have to add the 7 to the 2 before you can divide by 7. So, by that same reasoning, you cannot cancel these 5's. Leave them alone. We factor and then we cancel. So, let's factor this. Look at the numerator. I think that there is a common factor there. I see an x in both terms. I see a y in both terms. The smallest exponent that x is raised to is the first, and the smallest exponent that y is raised to is the first. So if we factor that out, what do we put in the parentheses so that we get x squared y minus xy squared? We need an x. That'll get us x squared minus. We need a y. How about the denominator? A common factor there of x. What do you have when you factor out the x? X minus y. Now, look at this. We have this factor of x minus y and this factor of x minus y, separated from the rest of the problem through multiplication. We have this x and this x. We can cancel all of that and get a nice, lovely y as our answer. I love simplification because it just makes everything so nice and neat. Factor the numerator, that's a special product, a difference of perfect squares. You should be able to do that quickly. Special products allow us to factor quickly if we recognize them. How about that denominator? That's also a special product. Did you get x minus 2 times x minus 2? What can we cancel? The x minus 2's. We are left with x plus 2 over x minus 2. Stop. Do not cancel anything else. The x plus 2, that's two terms separated by addition. X minus 2, two terms separated by subtraction. Cancel factors separated by multiplication, not terms. Oh, caution, caution, caution. Can we cancel this 2 with that 2? Can we cancel that x with that x? No, do not cancel do not spell that badly. Wait a minute. Do not cancel terms. Terms are separated by addition or subtraction. So you have this is a term and this is a term. You cannot cancel them. Opposites in rational expressions. Boy, that's something interesting too. This x minus 4 and this 4 minus x, you're tempted to cancel them because they look so much alike. But there's a trick involved. X minus 4, I wish the 4 were positive because the 4 in the denominator is positive. And I wish that that x were negative like the 1 in the denominator. So what I'm going to do is put a minus 1 out in front of this x minus 4. And what do I have to put in the parentheses so that I multiply and get a positive x? It's got to be a negative x. What do I have to put in the parentheses so that I multiply and get minus 4? It's got to be plus 4. Now think about that. If we multiply this, what do we get? Positive x minus 4. So we factored out a negative 1. Minus 1 times 4 minus x. Is it okay to write minus x plus 4 as 4 minus x? Yeah, it is. Let's cancel the 4 minus x's now. And what do you get? Minus 1. You'll see that a lot. Now look at the original problem here. When you have an original problem where you have a factor of x minus 4 and 4 minus x, or where one is the opposite of the other, you can cancel them and get a minus 1. That's all for this page. Let's stop there and go to the next video if you need to finish this chapter or this section.